This is Note Taking Guide 7.2 for Math 1. So today we're going to start a new chapter on mostly reflections, rotations, translations, where we're moving objects from where they were to another place. So we're going to start by just talking about how we're going to translate something. The word translate in math actually means to slide something. So we're going to slide the figure that they already gave us. They want us to move it 4 units right and 1 up. So really what we're going to do here is we're just going to grab these important points, the vertices, the endpoints here, and we're going to do exactly that. We're going to move them exactly where it told me to do. So I'm going to take this W one right here. I'm going to move it up 4. 1, 2, 3, 4. Oh, it didn't say up 4. I'm sorry. Let's get this straight. I'm going 4 right and up 1. So I'm going to go 4 right. So 1, 2, 3, 4, and up 1. So this is my new point right here for W. And then X is going to move right 4 and up 1. So 1, 2, 3, 4, and up 1. So my new point right here is going to be X. And then S is going to move right 4 and up 1. So 1, 2, 3, 4, and up 1. So my new point for S is going to be right here. And so what I really did there was I just translated that, or I slid that to its new location, which was right 4 and up 1 from its original. So again, a translate or a slide. This time it's written in a different notation. But if I take my x's and move them -2, that would be to the left, because negatives go to the left. If I take my y's and add 5 to them, then I'm actually going to be moving up 5, because y's that are positive are moving up. So I'm going to go left 2, up 5 is really what that says from my original graph. So from A, left 2, up 5 gets me a new point right here for A. B would be left 2, up 5, which is right here for B. And K would be left 2, up 5, which is right here. And my new shape is up there just like that. All right, the next one says reflect. Reflect means to flip. So this time we're not sliding, this time we're flipping. And it says flip it over the x-axis. So this x-axis right here is like a mirror image spot. It's where I'm going to take these ordered pairs and flip it over. So I like to do this. I like to look at V and I'm like, oh, I'm 2 away from where I flipped, so where should I be at? I should be 2 away from where I'm flipped when I end up. So I actually am going to have this new point down over here, which is going to be called V. Then I like to look at my next one. So Y is 1, 2, 3, 4, 5 away from where I flip. So 1, 2, 3, 4, 5. So right here, down here in the corner, is my new Y value. When we do our new ones, we put this little prime mark next to them. It means it's my new interpretation of that letter. So if it was V, it's now called V prime, which is that little mark there. Okay, then I'm just going to do L. So L from where it's at is 1, 2, 3, 4, 5 away. So 1, 2, 3, 4, 5 away, which is right here for my new L, which is called L prime. And my new graph looks just like that. It's flipped over the x-axis. Now, you guys, I want to talk about what that really means with the ordered pairs, because we're going to have to do some of this sometimes when we don't actually, want to count it maybe. So let's look at this. This Y ordered pair, 1, 2, 3, 4, 5, was up 5, over 5, and up 5. So my ordered pair was 5, 5. What did my new ordered pair become? It became 5, -5. Let's look at our V's. Our V's were over 5 and up 2. And now it's over 5 and down 2. So can you see what's happening there? If we flipped over the x-axis, then we actually changed our y values. Just changed the sign on the y values. So keep that in mind as we're going, because sometimes it's just easier to try to memorize the rule instead of try to find, the actual points every single time. And then L, I was over 3 and up 5, so this is 3, 5. So in theory, then, this should be 3, -5. which it is. If we count it, we're over 3 and we're down 5. So when we reflect over the x-axis, we change the sign on y. That's what we do, okay? All right, let's look at the next one. This one says reflect over the y-axis. So here's my y-axis right here. So I kind of like to do the same thing, but as I did before where I just counted it. So L is 3 away this direction. So I'm going to go 3 away this direction from the y-axis, and this is going to be my L prime. K is 1 away right here, so I'm going to make it 1 away right here, which is my new K prime. And then V is 1 on this side, which means I got to put it 1 on the other side, which is over here for V prime. So my new shape is coming through like this. Okay. So let's see if it followed the same thing. So on the X, the reflection over X, we changed the signs on Y. Did we change the sign on X this direction? Let's look and see. Well, my original V ordered pair was 1, 1. My new V ordered pair, or my V prime, is negative 1, 1. I just totally called those ordered pairs wrong. Somebody needs to slap me side the head. Okay, V is 1, 0. My bad. And the new one is negative 1, 0. So did that work? If we reflect over the y-axis, did we change the sign on the x value? We did, even though I wrote the ordered pair wrong the first time. Let's check our L. Our original L, 1, 2, 3, was negative 3, negative 1. Our new L, which is L prime, is 3, negative 1. So I did, again. So when we reflect over the y-axis, we change the sign on our x values. So just keep that in mind as we keep going. Okay, we're going to reflect over the line y equals 1 this time. This is my y-axis. I'm going up to y equals 1, so this is my line of reflection right here. So I'm going to reflect everything over that line. I'm just going to count it like I did last time, you guys. I think that's the best way. P is 1 away from that line of reflection. I'm going to put P away. That's my new P prime right there. Okay, F is 1, 2, 3, 4 away. So it's going to be 4 away. 1, 2, 3, 4. This is my new F prime. And then I is 1, 2, 3 away. So I'm 1, 2, 3 away. So here's my new F prime. My new shape down over here like this, reflected over the y-axis. I mean, not the y-axis, the line y equals 1 this time. Okay, reflect the image over the line x equals negative 2. So this time on the x-axis, I'm over here at negative 2, which is right here. It's still going to work the same way, you guys. This one actually is going to have to stay where it's at because it's on the line of reflection. So we're just going to leave that one where it is. And then this one is 2 away here. So I'm going to move it over here to 2 away. This one is 1, 2, 3 away. So I'm going to move it 1, 2, 3 away the other side, which is right here. And so I'm going to be just like this for my new reflected image. All right, so now it wants us to do it without actually looking at the pictures of them. So this says translate A, which is these ordered pairs right here, 13, negative 7. It says move it 6 to the left and up 2. Well, left and right is the first ordered pair. Up and down is the second ordered pair. That's the way our ordered pairs work. So if I need to move 6 to the left, I'm actually subtracting 6 from this. So 13 minus 6 is 7. And then I'm adding 2 to my y value. So a negative 7 plus 2 is a negative 5. So my new ordered pair is 7, negative 5 for A prime. Okay, ordered pair starts out 13, negative 7. I want to go 3 right, which is adding 3 to my x values. And 9 down, which is subtracting 9 from my y values. So 13 add 3 is 16. Negative 7 minus 9 is a negative 16. So my new ordered pair is going to be 16, negative 16. All right, this is a reflection over the y-axis. Does anybody remember what we do when we reflected over the y-axis? We actually changed the signs on x. So x has become negative 13, and then I'm still negative 9. And then this one says reflect over the line x equals 3. So when you're having a hard time visualizing where that's going to go, the best thing to do is just draw a real quick graph of it. We're going to be over 6 and down 5. So 1, 2, 3, 4, 5, 6. Down 5. Our ordered pair is going to be over here in this corner. And I need to reflect it over the line x equals 3. So 1, 2, 3 right here. So that ordered pair is how far away from 3? Well, it's 3 away this way, which means I'm going to be 3 away this way, which means I'm coming over here to 0. So my new ordered pair for that will be 0. Actually, yeah, 0, negative 5. All right, so sometimes I just like to draw it out real quick because it's easier than it is to try to figure out the algebra behind where it's moving. Okay, these next ones ask us to write a rule to describe the transformation. So that's what we're going to do here. We're going to write the rule. So we're starting with our original, moving to our prime. So if you see the little prime marks on these, this tells us it's our new one. So how did we get from n to n? Well, we went over 2 and down 4. So we went right 2 and down 4. So that means right 2 would be our x's. We added 2 to them. And our y's, because we went down, we subtracted 4. So my original ordered pairs, x and y, changed to x plus 2 and y minus 4 for my rule. All right, again, look for your primes. This is the one we changed to be, so let's see if we can figure out what we did. Okay, this is definitely a reflection. I can see the reflection happening because it's not the same shape moved. It actually flips this one from here up to over there. So this is a reflection over the x-axis. So really what we did, if we wanted to try and write a rule, is we took our x's and our y's and we changed them. If you remember our x's and our y's, our x's stay the same if we're reflecting over the y-axis, but we changed our y's to negative. So if they were negative, they changed positive. If they were positive, they changed negative. So here's my rule written out for that reflection over the x-axis. This one is again a reflection. You can see that it's being reflected over this line right here. So this line is x equals 1. So they get a little more complicated to write the rule right there. And I'm okay if you just write that it's a reflection over x equals 1. All right, next problem. This one right here, what did we do? It looks like a slide. So how do we get from J to J prime? How far over? How far up did we move? Well, we moved over 1, 2, 3, 4, 5, 6. So 6 to the left. And 1, 2, 3, 4 up. So 6 to the left, 4 up. Did it work the same on the Z? Yeah, 6 left, 4 up. So that means our x's and our y's started out as x and y's, and we moved 6 to the left, which is a minus 6, and the y's went up 4, which is a plus 4 for our rule. All right, write the rule for the translation from 4, negative 2 to 6, 3. So what did I do to my x's? I added 2 to them. And what did I do to my y's? I actually added 5 because I went from a negative 2 to a positive 3. So my original x and y changed to this. And then the last one here, my y's actually stay the same. So it looks like I just moved. Oh, actually this one says it's a reflection. So I am not super good at algebraically figuring these out. So I want to show you again that you can just graph these really fast to see what happens. So if we start at -2, -7, so -2, 1, 2, 3, 4, 5, 6, 7. If we start at -2, -7, which is right here, come on, draw me a point right there. Okay, and we end up at 5, -7. And then we're down here. Okay, so how far did that change me? Well, I started here, and halfway in between there would be my line of reflection. All right, so I kind of drew out where I started and where I ended. If I'm over here at -2 now, and then I end up over here at 5, how many movements is that? That's 1, 2, 3, 4, 5, 6, 7 movements. So in order to figure out where that line of reflection would happen at, it would be 7 movements divided in half, so 3.5 movements. So 1, 2, 3.5. And then that leaves me with 1, 2, 3.5. So this is a funny reflection because this actually reflects over x equals 1.5 is what I believe that is to be. All right, so we're just going to say it reflects over the line x equals 1.5. All right, you guys, thanks for watching. If you have any questions, come see me at my desk. Good luck on your homework.